Yes, so we have discussing about different sorry, we are discussing about different factors for we're discussing about different types of our services. Okay, means locomotive services or EMU services. Then we were discussing about what are the different types, okay, and different speed. Okay, suppose we discuss about the peak speed, average speed, schedule speed. Then what are the important factors for that can affect to the speeds. Okay, then we are discussing about, okay, what are the factors. Okay, so that's very important. So what was the important speed? First was there the crest speed, okay, means maximum speed. Okay, next one is your average speed. Average speed means total distance between the stops divided by actual time of run, meaning how much time, that the durations. So that one. Then schedule speed means total distance, okay, between the stop divided by actual time of run plus stop time means stoppage, how much time you are waiting for there. But I think you are able to understand the difference between average speed and schedule speed. Okay, so in this case, average speed, the denominator is less compared to the schedule speed. Okay, if denominator is more in schedule speed, so that value of schedule speed definitely less than your average speed. That's why it is written that always schedule speed is less than of your average speed. Okay, simple thing. As additional thing is the stop time is there. Difference is the large in cost of urban and suburban. Negligible small in case of mainline service. Why that is small? In mainline service, you can see the stoppage given minimum 2 to sometimes you can see some of the station 15 minutes. So cooling also required after continuous running of some duration of the locomotive, then cooling is required. So in this case, you can see the motor duties are different. Okay, urban and suburban, they are in intermittent nature. So rising up, rising down, again rising up, rising down, rising up, rising down, like that. So what are the factors that can affect your crest speed, average speed, and schedule speed? Okay, so here we are considering about the schedule speed. Why the schedule speed? Basically, in case of schedule speed, we are considering about the stoppage time. Okay, for what durations we are giving the stoppage duration. That's why it is important. So schedule speed of given is effectively by following factors. What are the following factors? Number one is your effect of acceleration and braking retardation. Okay, acceleration and braking retardations. Okay, for the given run with the fixed crest speed, the increase in the acceleration will result in the decrease in actual time. So more increasing that value means result definitely will be less than your actual time, and therefore increase in the scheduled speed. Similarly, increase in braking retardations will affect the scheduled speed. So braking effects is there, so automatically it having the effect. The variations in the acceleration and the retardations will have more effect on the schedule speed in the case of the shorter distance run in the comparison for the longer distance run. Okay, so if it is running for longer duration, so definitely stop time will be more. If it is running for shorter duration, stop time will be less. Basically for what, you know that urban and suburban. For suburban, you can see, sorry, for urban service, the duration between two stoppages maximum 3 to 5 kilometer, in between 3 to 5 kilometer. But in suburban, that maybe quite more. It is minimum 5 to 8 kilometers minimum. Okay, minimum 8 kilometers like that. So most of the time, so duration also being different, stoppage durations. Okay, as well as the speed, so it cannot reach up to that amount of speed. So speed reaching, then retardation directly. So that amount of motor duty is cannot be completed for these cases. Okay, the effect of maximum speed. If you want to, for constant distance is there, run and with the fixed accelerations and retardations, okay, the actual speed will run decrease. So if you increase maximum speed, so runtime will be decreased, common sense. Okay, therefore the schedule speed will increase and runtime will decrease means what? Here you can see actual runtime will be decreased. Okay, so schedule speed will be increased. Okay, so increase of the crash speed. Okay, the effect of the variations of the crash speed on the schedule speed is considerable in case of long durations of run. Okay, effect duration of the stop. Okay, for the given average speed, the schedule speed will increase by reducing the duration of the stop. So definitely reducing means schedule speed will be increased. Okay, basically stop duration increase, the stop duration reduce means definitely your denominator is reduced, so automatically schedule speed will be increased. For the variations in duration of stop will affect the schedule speed more in case of shorter distance run as compared to the long distance run. Okay, so it takes some less time. Now we go for the important thing that we are giving the shape. Okay, normally there are two types of shapes we are considering for our speed time curve. First one is that for your mainline service, that if you see the diagram, it's look like that main speed curve characteristics. It's look like a mainline service. Okay, the costing. Okay, then a free running, costing and retardation. All the modes are there. Okay, so here free running modes are not there, directly costing. Okay, and retardation. So you say like that, breaking. So that figure is associated like that when you are calculating the total distance. Okay, speed time characteristics, it is your speed and it's your time, speed time characteristics. So what you need to do, you have to you have to assume the shape. Okay, how is it will look like that? Okay, assume shape means in this case mainline service normally we are considering trapezoidal. Okay, trapezoidal speed, approximated trapezoidal speed torque curve. And in this case where you can see that approximated, it's not the trapezoidal, it is quadrilateral. Okay, quadrilateral speed time curve. Okay, mistakenly it is written trapezoidal, but it is quadrilateral. Okay, this one. The simplified speed time curve, the convert or the replace the typical speed time curve to simple geometric shape curve is known as the simplified speed time curve. Okay. From this simplified curve, the relationship between the acceleration, retardations, okay, accelerations, retardations, average speed and the distance can be easily worked out. Okay. From the trapezoidal curve can be used for the mainline service and quadrilateral curve. So this is your quadrilateral curve, this is trapezoidal. Can be used for the urban and suburban service. Okay. So generalized structures, okay, we can consider for this case. One is urban service. For urban and suburban we are using quadrilateral shape, and for trapezoidal we are considering for mainline service. Okay, so here you can see the calculations by the trapezoidal speed time curve. Okay, so what is that calculations? From the calculation you can see the trapezoidal speed time curve, the time is in your x-axis and speed is in your y-axis. Okay, so here you can see total time period is t. Okay, total time period is t. It is your t1, t2 and t3. Okay, total duration. So for first case, what was there? So alpha is there for the accelerations in kilometer per hour per second. Okay, so at the time of exam you have to convert it. Okay, you have to convert it as per your requirement. Okay, then beta is the duration for the retardations. Sorry, it is acceleration alpha for this first case and second case. Okay, second case beta is there, retardations for this zone, second zone, and Vm is your what, crash speed in kilometer per hour. Okay, and a maximum speed in kilometer per hour. Okay, and t is the total time of run. Okay, after that it will stop. The time for accelerations is simple. Okay, you know that yeah, is you know that y-axis what is there, it is v. Okay, so AT, you know that S equal to AT, like that. Okay, so first one, it is your V. Okay, V maximum, that's why it is called V max, crest speed. So V equal to Vm equal to alpha into T1. So what is the value of T1? T1 equal to Vm by alpha. I hope you are all of you able to understand. Okay, if any confusion is there, please let me know. Again, I will discuss. Okay. For retardations, okay, for retardation in second, T3, that was your T3, T3 is there. Okay, T3 equal to what? Vm by beta. Okay, so Vm equal to beta into T3. Okay, so Vm by beta. So what is your free running condition? T2. So free run in T2, T2 equal to capital T minus T1 plus T3, T1 plus T3. Okay, so it is coming to capital T minus T1 value equal to Vm by alpha plus T3 value equal to Vm by beta. Okay, so you can take a common, so total distance run in kilometer is capital S equals to distance travel during the acceleration, that is S1 plus distance travel during the free run conditions, during the acceleration, during the free run condition, during the retardation. So total S equal to total travel distance is equal to S1 plus S2 plus S3, as simple as it. So how do you calculate the S1? Half base into height, base equal to T1, height equals to Vm. That one is your rectangle, so you can multiply your width. Okay, width into height, width is equal to T2 into Vm will be there. So T2 equal to what? Capital T minus within bracket, or you can say within a T1 plus T3, or you can say like that, this one. Okay, capital T minus within bracket Vm by alpha plus Vm by beta. That directly you can do. Okay, for free running condition. And next one, during the travel during the retardations, same thing, half base into height, base equal to T3, height equals to Vm. Okay, you can able to replace the value. Okay, here S1, S2 and S3. Okay, now I have that value S1 that I am telling you, so half base into height. So now you are converting them. Okay, converting which value in second. Okay, that you know that was kilometer per hour. Okay, so that's why you are converting to the second. Okay, so hour one for VM you are converting, for T1 again you are converting. So that's why 3600. You are able to get that value. You know the value of T1 equal to Vm by alpha from your previous case here. T1 equal to Vm by alpha. Okay, so simple thing. Okay, nothing complicated at the time above exam. That simple problem will come. Okay, for S2, okay, for S2 equal to Vm T2 by 3600. Okay, so again you are converting to the second. You know the value of T2, just I am discussing just now. Okay, T2 equal to capital T minus within bracket Vm by alpha plus Vm by beta. Okay, so S2 you are able to get S2 equal to Vm by 3600 T capital T minus all those things. Okay, so directly you are getting those value S2. So we are money. Yeah, now you are equating that value of S2. Okay, it is coming, you know, after multiplication you can get those value. Then S3, for case of S3, okay, S3 equal to what? Half VMT3 whole divided by 3600. You know the value of T3, Vm by beta. Okay, so S3 directly you are able to get Vm square whole divided by 7200 into beta. Now you are replacing them. Okay, you know that total expression capital is traveled area, that is equal to, okay, S traveled speed is equal to S1 plus S2 plus S3. Now you can replace the value of S1. So this is your S1 you are replacing, then S2 you are replacing, okay, and S3 finally. So you are equating all of them. Finally, you will get a quadratic equations. Okay, so here you are getting one quadratic equations. Okay, now you know that K, you are considering capital K, that is constant one by, not constant, you are taking consideration K equal to within bracket 1 by 2 alpha plus 1 by 2 beta. Okay, so now you can see it's a quadratic equation. you can equate it, you can get the roots from the quadratic equation by using the Siddharth formula. So you're getting the maximum speed. Okay, so two roots are there, plus minus. So you have to place all the value and you need to check what is the exact value of Vm. Okay, after getting that exact value of Vm, you can see, so Vm value should be greater than 0. Negative speed is not possible. So for positive sign will much higher value than the possible in the practical value. So to take negative sign for the calculations. Okay, so they are doing the calculation and let's observe that positive thing is not appropriately work. So only negative signs are taking. So what you need to do, you have to replace the given value to that equation, to that root, and find out the root. Okay, so positive value you should consider. Okay, I hope you all of you are getting my point. So any doubt till now? Is there any doubt from your end?
No, sir.
Okay, good, very good. So then we can see for the quadrilateral calculations for the quadrilateral. Okay, so in quadrilateral calculations, you can see that alpha equal to, there are alpha for the accelerations. Okay, alpha is here for acceleration in kilometer per hour per second. Beta c, okay, here you can see that beta c is there. Sorry, beta c is here, coasting speed. Okay, this is your coasting. Okay, beta c is there for coasting retardations, and beta is for total normal retardations. Okay, from here, okay, this is your beta and it's your coasting retardation beta. So you know that v1, v1, v2, v1 is the maximum speed at the end of acceleration in kilometer per hour. Okay, v2 equal to what? Maximum speed at the end of coasting in kilometer per hour. Okay, and t equal to a total time of run in second. Okay, t equal to total run of total run time, t1 plus t2 and plus t3. That is your total t. Okay, so now as simple as it like that. So first you need to calculate, it is your maximum speed v1 and another speed is there from maximum speed to return, that is v2. So first thing is that for the acceleration, simple thing. So t1 equal to v1 by alpha. Now, okay, for retardations T3, okay, for retardation T3, V2 by beta. Okay, basically for previous case that there is a free running condition. So maximum speed was only 1 Vm. But in this case, so maximum speed it is touched with V1, then it goes to V2, then it goes to 0. That's why V1 and V2 both are there. For free run, actually this time for your coasting time. Okay, that is your coasting time is how much? Total whole speed variations V1 minus V2 whole divided by time durations. Okay, sorry, whole divided by, you know, the time durations that you need to find out. So divided by your retardations at your coasting condition. So beta c, coasting condition, retardations. Okay, so it is coming v1 minus v2 whole divided by beta c. Okay, retardation for coasting duration. Quadrilateral speed time curve. So total distance of run in kilometers. So it is coming distance traveled during acceleration. Okay, that is your first case. Distance traveled during the coasting period. Okay, how much duration is traveled. And finally, the distance traveled during the braking condition. So S equals to, again same, S equals to S1 plus S2 plus S3. S1 equal to half base into height, base equals to your T1 and height is V1. So half V1 T1 whole divided by 3600 for S1. And S3 again it will be like that, S3 equal to half V2 T2 T3 whole divided by 3600. And for the second case, okay, for the coasting period, so what is your travel distance? You know that S equal to UT plus half AT square. Okay, so so what is your value? That ut equal to your initial sorry, ut equal to how much value is it there? So initial value, that is your v2 t2 whole divided by, okay, v2 t2 whole divided by 3600, and how much the speed? Okay, so how much s2 equal to actually what? That area. Okay, total area is you need to calculate. Okay, so this area. Okay, so area, that direct formula is there. So direct area, how much is it? Okay, so up to this portion is your rectangle. Okay, rectangle. Okay, rectangle means basic rectangle width is T2 and height of the rectangle is V2. Okay, so directly you can write down the T2 into V2 rectangle whole divided by 3600. So you are making them. So you are converting in the second, and that triangle is there. So half base into height, base equal to what? V1 minus V2, half V1 minus V2 whole divided by base into height equals to this one T2. Okay, half base into height T2. Now whole divided by again 3600 for conversions in the second. I hope you are getting my point. Now you equate both the term and you will get that V1 plus V2 whole divided by V2 into T2 divided by 3600. So you'll get the value of S1, S2 and S3. So now you are replacing them S1, S2 and S3 value. So after replacement you will get that value S equal to that, and you will get the equations finally. You know the value of t equal to t1 plus t2 plus t3. Okay, so now you are replacing all of them. Okay, you are replacing all of them. So s finally you can able to calculate. Okay, so t1 equal to v1 by alpha. So you are also replacing the value of t1 and t3. So finally you will get the expressions of, so t2 expressions also be there. Here you are able to get the value of t2. So finally you are able to calculate the v2 in terms of beta c, and in terms of beta and beta c. Okay, costing retardations, sorry, alpha হচ্ছে accelerations, beta is your retardations, and beta c is your costing retardation. So you'll be able to calculate the value of v2. So, and if you are able to replace the value of v2, automatically you will get the value of v1. Okay, you have that all those two value, automatically you are able to calculate the value of s. Okay, so simple calculations, nothing complicated. So you can practice it in your homework copy. So, and the similar type of numerical problem you have to solve at the time of exams. Simple numerical problem will come from this by using these equations. Okay, so what you need to do at the time of exam, so you have to derive that basic one. Okay, and put the value to get the answer. Okay. Now, mechanics for the train movement. So every day we are talking about that pinion gear joining. Okay, pinion gear joining. So where we can see, okay, so it is your pinion gear joining. So first wheel. Okay, so it's your so bigger one is your wheel and it is your pinion. Okay, so wheel, both of the wheels are connected. Okay, both the wheels are normally connected through the shaft, and shaft there is a gear and pinion gear joining will be there. Okay, so movement of that shaft. Okay, sorry, as per the rotations of your machine, the motor, that you are giving, the you can transform, okay, the energy, the mechanical energy is transformed from your motor to shaft wheel. Okay, motor to wheel, sorry, shaft of the wheel through that pinion gear joint. Okay, so you can see the area, cross sectional area is less here. Okay, so number of rotation also more, but here you can see the number of cross sectional area is more, so number of rotations will be less for conservation of energy, whatever exact RPM you want to get. So based on that, everything will be decided. Okay, so here you can see that armature of traction motor. Okay, armature of traction motor you are able to see, and next one is your pinion motor. Okay, so pinion motor also be there, directly connected with that armature also, it's possible. Okay, so road wheel and gear wheel. Okay. Road wheel means what? Road wheel directly connected to the shaft. Two wheels are there that normally come stand up on your railway track. This is your road wheel or outer wheel. Okay, and gear wheel will be there. in the both the shaft. Okay, so two wheels are coupled each other. So one wheel having some that wheel having some gear joining. Okay, so that pinion is directly connected with the gear. So movement of traction motor may cause for movement of pinion. Okay, so movement of pinion means that may cause for movement of your gear. Okay, basically pinion gear joinings are there. So movement of gear means definitely that railway wheel. Okay, EMU wheels also start rotating. Okay, so this is the way. So energy is transformed from that electrical energy or chemical energy to the mechanical energy. Okay, so through that pinion we are gearing. So what are the important factors are there? Okay, so here you can see road wheel and gear wheel. What are the important associate factors are there? So first one is your what torque exerted by the motor. Okay, what type of torques are there? Next one, F dash equal to tractive effort at the pinion. Okay, how much effort is there? F equal to tractive effort at wheel. Okay, wheel. And D is diameter of the pinion. D dash. Okay, diameter of the pinion. This is your pinion motor and actual armature traction motor. Okay, armature traction motor directly connected to the gearing ratio. So gear is there. Okay, at the side of armature. So dynamometer of the rear gear. Okay, small d is the dynamometer of the rear gear, money backside gear. Okay, and the capital D is dynamometer of the road wheel. So how the wheel is rotating, okay, that you are handling. So, but directly they are associated each other. Okay, now here you can see one gamma. Okay, gamma equal to what? Gear ratio, that is D by D dash. Okay, total D. Okay, so D is your gear wheel and D dash is your pinion diameter. Okay, so efficiency of the transmission. You can easily calculate the efficiency of the transformer, transmission of the railway track. Okay, let the dividing. Okay, so let the driving motor exert the torque T in the Newton meter traction effort at the edge of pinion is given by. So that's given. Okay, formula is given. T equal to F dash D dash by 2 or F equal to 2D by D. Okay, these two are the basic equations for here. Okay, for the torque equations. Okay, the tractive effort under transfer. Okay, tractive effort can transfer the driving wheel. Okay, so driving wheel it can possible. So F equal to what? F equal to N F dash into D by D. So energy is transformed from main system to driving wheel. So some of the you will be lost. Okay, so that's why efficiency is directly connected or associated with the system, how much efficiency you are getting. So if it is poor efficiency, so you have to consider how would you able to improve the efficiency, system efficiency. Then F equal to what? F equal to N efficient meter 2t whole divided by d dash within bracket lowercase d by an uppercase d. So directly you will get that value. Okay, how much f you are able to get from here. Okay, then capital F equal to n phi. Okay, nt and 2 zeta by d. Directly you are able to equating them and finally you will you are able to get it. Okay, so what is the force? Okay, we are doing the force calculation. So F is there, another F is there, F dash it is your rotation purpose money directly. Okay, coefficient of additions, what are the important coefficients are there? Okay, so first you can say like that the maximum friction force between the driving wheel and the track is megawatt. So first problem is that how much energy efficient, how much your planning skill, how do you make it energy efficient. So that you need to you need to think. Okay, so when co-effective or sorry mu equal to what, mu equal to co-effective of the additions between the driving wheel at the track. So addition force between driving wheel and the track, that is your mu. Okay, or you know like that friction constant. Okay, and W equal to what? Weight of the train on the driving wheel. Okay, how much weight is it? That means how much load is taken care by the driving wheel. That you need to again understand. Okay, so these all are the very important factors. Okay, so motion of the train without slipping. Okay, so if less than mu w, then coefficient of addition, that is your mu. Then factors, then sorry, tentative effort to slip the wheels, whole divided by additions, additive speed weight actually. Okay, so mu value, how much it will be there on table is there, and which contain the addition addition of that coefficient of addition. Okay, mu equal to 0.25, 0.18, 0.4, 0.14, 12, 10, 0.990, and you can also get a similar type of thing for 0, 15, 30, 45, 60, 75. Okay, for cleaning the dry gel, so you can make it into 0.25. So how much you are maintaining the device, so it's also been less value. Okay, so if the values are not so much, if the values are not so much convincing, so you have to think about it for the alternative options. Okay, for getting the, so the mu value will be 0.08. Okay, so this is for special case, that's why you can see that mu value is less. Okay, so depends upon, so from which value, from which parameter, depends on that situations. Okay, factors, which parameters factors here depends on friction between the wheels and the railway track, so it's important point. Next one is the series parallel connections of motor. Okay, so that also been discussed, so that is also very important thing. Speed of response, the drive, so how much speed you are getting from the drive, that's important. And smoothness with which the torque can be controlled. Okay, so all of the very important features. Okay. Name of the name of the motor torque, nature of the motor torque, speed characteristics based on that your motor performance. Okay, as per the requirement of the motor with the load. So what kind of performance you need to check, so that you, after finalizing that value, so you can use them. Okay, and here you are getting the idea from the table how it is working. Then most important factors, that is your tractive effort. Okay, so how it is working, that's very important for the tractive effort. So in case of tractive effort, okay, force necessary to propel, to start rotating the train at the wheel of the locomotive called the tractive effort. So when the rail is going to start. Okay, so initially what happened? Huge thrust is required. So huge force is required. So that's why you have to consider for the DC series motor. Okay, so huge torque is required to overcome the friction of the railway track. That's why it's there. Okay, then the total tractive effort, total tractive effort required to run a train on the track. Okay, the tractive effort required for linear and angular acceleration plus tractive effort to the observation and the effort of gravity. Okay, the effect of gravity and tentative effort become the main become the train resistance. Okay, so it's a huge inertia, so it can counter its changing the, it's having the basic change, no? As per Newton first law. So it's giving the objections to if you want to change them. That's why it's very important. Okay, so here what are the most important factors for it? So first one is the tractive effort for acceleration. Okay, here you can see the tractive effort for acceleration. So according to the law, you know the formula, force equal to mass into acceleration, you know directly. Okay, mass equal to Newton, acceleration is alpha. So kilogram per mass per second, okay, per minute per second. Okay, so W equal to ton, within bracket weight on weight on the train. Okay, m equal to 1000 weight per kg. So acceleration for acceleration for localized condition, you need not to, nobody need not to accelerate that value. Whatever is required, automatically it will reach to that place. So for the quite distance, it is acceleration, whatever value is there, so that should be multiplied with that value. Okay, alpha, so it's multiplied with 1000 by 360, whatever required. So tentative effort, okay, required for linear acceleration. Okay, so if alpha is there, m into alpha, so directly you put those value and you will get some parameter. Okay, force parameter. The rotation, the rotating part of train, such a wheels and the motor, as simple as it, rotating part. So traction generators are there, you will give the supply, and that supply directly cutting with that creamy that supply directly uh, working with here. Okay, so tractive effort required for the linear equation. So some equations are there for the linear equation. So you can implement the formulas to your work. Okay. For rotating part of the train, such as wheel, motor was also accelerate in the angular direction. The tractive effort, okay, the tractive effort required to equal the tractive effort required have the angular accelerations. Okay, so these are a lot of the very important points, angular accelerations, and what you can see the tractive effort for the propulsion train. Okay, so the effect for the free angular acceleration. Okay, what are the angular acceleration? Angular acceleration depends on the individual weight and others. Uh, weight and individual weight and radius with gyrations, means your earth detector, that means earth detector directly you are using for it. So we equal to what, equivalent as acceleration weight of that train. Okay, and EA equal to what? EA equal to 277.8 WE alpha. So how their values are coming directly, it's all of the standard value. You can also follow any of the or cross check any of the book, you will get the same type of value. Okay, now what you need to do? So tractive effort to removing the tractive effort to overcoming the effect of the gravity. Okay, sometimes what you can see, the train need to climb against the gravity sometimes. So where it is important. Okay, along with the slope acts on the real train and trains the and trains to cause its motion down to the gradient and the slope. Here you can see the different here you can able to see that different component of your force, okay, or the traction. So directly you will get it. So force due to guideline eg equal to 1000 w sine theta in kg, and percentage of quadrant is given that g%. Okay, so you know that g equal to 7 g equal to sine theta, g dash equal to 10 into sine theta, sine equal to g% into 1100, and directly you can make as per your appropriate quantity, and you can directly any of the restaurant you can give it for that one. Okay, so travel effort to overcome the chain resistance that I have already told you. So normally what we are using, that ice bag. Okay, sorry, so sorry. So here you can see the tractive effort. Okay, tractive effort to overcome the chain resistance. What are the important factors are there? So previously you can see when it will be in inclined one. Okay, so what you need to do, you have to use the formula Fg equal to 10 Wg%. G% is your gradient. Okay, so you have to calculate that value, and finally here you can see that equivalent acceleration of the weight of the train Okay, so after running, that weight may be quite reduced. So immediately you can implement other formula, but at the starting is get problem. Okay, directly it's not a try to start it. Okay, so train resistance consists of the forces, resistance, motions of a train when it is running uniform speed on a straight on a straight and lever tracks. Okay, almost in linearly running. Okay. So train resistance, the friction at the various part of the rolling stock, friction between the track and the wheel, and air resistance. These three are the basically train resistance. In general equation, the train resistance given by R equal to K1 plus K2 V plus K3 V square. So K1, K2, K3 are constant and depend upon the types of train and track. R is resistance in Newton, V is the speed in kilometer. Okay, so you can convert them to get that one. Okay, so tractive effort required for the overcome the train resistance E equal to W into lowercase r into Newton. Okay, so the sign the specific chain resistance and the number of dead weight. Okay, W n equals to number of dead weight. Okay. So here we can see the train locomotive. Next class we will discuss about the train locomotive. So today this up to these portions we are here total tractive effort. You know that ft value equal to f alpha plus fg plus minus fg, sorry, f alpha plus minus fg fr. Okay, again ft equal to, you'll get the formula 277.8 w alpha plus minus 98.1 WG% plus WR. So how they are coming directly, you can cross check it. You can follow any of the standard book and cross check it. Then mathematics. I told you already that it's required. Okay, at the time of exam, that basic mathematics will come and changing with the values of numericals. Okay, so this type of thing will come at the time of exam. So that's why you try to solve this type of problem to your home. Okay, so you should not face any kind of difficulties. Okay, I hope all of you are able to understand. So in my next class we will start with from AC locomotive, some important features we are going to discuss. Okay, so so that we can going to discuss. Okay, so I hope all of you able to understand what you need to do. Okay, so this portion is simple, nothing complicated, only some numericals. Basically, we are giving more trust on numericals. Okay, so in from these portions. Okay, so try to solve some numerical problem to your home or hostel, so we can directly. Some of the problem I have also discussed in next slide. Okay, some of the slides, so you can do it by yourself also. And any confusion, you please ask me. Okay, I hope you are able to understand. Any queries from your end?